Hello students, in this video we are going to discuss about basic coordinate geometry. So in this session we mainly focus on plotting graphs. Okay, so first of all look at a straight line. If suppose the relation between y and x is linear, that means y is proportional to x. That means if x increases, y increases proportionally. If x decreases, y also decreases proportionally. Now if you want to remove this proportional, you have to replace with a proportionality constant k. Now this one becomes y is equal to kx. This is a straight line equation. Now this becomes, if you bring x over here, this becomes y upon x is a constant. Let us verify for a straight line graph y upon x is constant or not. For that purpose, take this example. Here I have taken this graph as an example to verify in case of a straight line whether y upon x is a constant or not. Okay, so on x-axis the scale changes as 1, 2, 3 and 4. On y-axis the scale changing as 2, 4, 6 and 8, for example. Now the very first point is x coordinate is 1, y coordinate is 2. Now for this point let us verify y by x ratio. Okay, now y is 2 here and x is 1. So we get y by x as 2. Now second coordinate, x coordinate is 2, y coordinate is 4. So again verify y by x. So here y by x is 4 upon 2. Again it is 2. Next verify for the third value. X coordinate is 3, y coordinate is 6. So y coordinate 6, x coordinate 3. Again this ratio is 2. So if you check for several values over here, always this y by x is a constant. Okay, that means in a straight line y is proportional to x and this y by x ratio is always a constant. These are the main points about a straight line. And this y by x ratio is also called slope. The other name for this y by x is called slope. About slope we'll learn further in this video. So for a straight line the slope is constant. We can say that the slope is constant for a straight line because the y by x is constant. The slope is also constant for a given relation, straight line relation. Okay, now the standard straight line equation is y equal to mx plus c. I hope most of you are familiar with this. The standard straight line equation is y equal to mx plus c, where m is slope, okay, and c is a y-intercept. Okay, what is y-intercept? Y-intercept is when you put a x value to 0. When you put this x value to 0, whatever the value comes here in place of y, that is what y-intercept. Okay, remember y-intercept means in the standard equation y equal to mx plus c, put x value to 0, then whatever the y turns out to be, that is y-intercept. Okay, so here y is equal to mx. In the first graph you can see there is no c over here, it is 0. So y is equal to mx. So if you put x value to 0, y value is also 0. So the graph starts at 0 comma 0. This is the graph for y equal to mx. Now what about y equal to mx plus c? Now again c is the y-intercept. That means if you put x value to 0, then y value is plus c here. Y value plus c. When x is 0, so this point coordinate is x coordinate is 0, y coordinate is c. So when you put x value to 0, y value is c. That means when x is 0, y is c. So the graph starts here, and since there is a linear relation between y and x, the graph will be a straight line. Okay. Now next graph is y equal to mx minus c. So here again, if you put x value to 0, y is minus c this time. Okay, so this point over here, its coordinates are 0 comma minus c. Okay, So when x is 0, y is minus c, and the graph starts from here. Since there is a linear relation between y and x, the graph goes like this. Okay, so the point to remember is whenever there is no y-intercept, the graph starts from origin, and whenever the y-intercept is positive, the graph starts from here, and whenever y-intercept is negative, the graph starts at a negative y-axis. Okay, let us move on to next slide. Here let us learn more about slope. Slope is basically the ratio of difference in y and difference in x. That means as y changes or as x changes, y changes, or as y changes, x changes. Okay, so how much difference comes in y? Proportionally, there is a difference comes in x. So the ratio of change in y to change in x is basically called slope. Okay, now delta y is what? In terms of trigonometry, now see, if you make a triangle over here, out of this graph, if you make a triangle over here, here y is the opposite side of this triangle and x is the adjacent side of this triangle. So what is the ratio that involves opposite and adjacent? Correct, that is tan. Okay, so here opposite side is delta y and adjacent side is, one moment, here opposite side is delta y and adjacent side is delta x. So tan theta is basically what? Change in y upon change in x. That means slope and tan theta are same only, no? So slope we are defining it as delta y by delta x, and also tan theta we are defining it as a delta y by delta x. That means if we calculate tan theta, we are getting the value of slope. Okay, so to understand this more better, let us look at a few more graphs. Now first graph, the slope is 0. Why slope is 0? Suppose the graph is like this, a line parallel to x-axis. Here there is no angle at all. It is not at all making any angle with the x-axis. So angle 0 means tan theta 0. That means slope is 0. For any graph like this parallel to x-axis, the slope is 0. Okay. Next, second graph, the graph is like this, which is making some acute angle. You know acute angle which is less than 90 degrees. Okay. So here again slope is what? Tan theta. Okay, tan theta value for acute angles is positive, isn't it? Tan 30 is positive, tan 45 is positive, tan 60 is positive. So what are all the angles less than 90 degrees? The tan value gives you positive value. So here as long as this graph is making acute angle, the slope is positive. Okay, now look at another graph. Here the graph is somewhat strange. It is like this now. Now the angle is obtuse. The angle is obtuse. That means angle is more than 90 degrees. So for the angles more than 90 degrees, the tan theta value turns out to be negative. That means slope is negative. Remember, whenever this tangent, whenever this line is making obtuse angle, the slope is negative. Okay. For suppose, look at this graph. Suppose the curve is like this. Okay. I want you to find slope at certain point. I want you to find slope at this point. What you will do? Since it is a curve, you cannot take directly. You cannot directly calculate slope. Okay. So at this point, what we will do? We will draw one straight line. Now look at this. This is making acute angle. So the slope at this point is positive. Slope at this point is positive. Suppose let us take one more graph to understand negative slope. Okay, so let us take this graph. Suppose graph is like this. Okay, now at a given point, again, suppose the point is given here. Here you want to find the slope. So here draw one tangent, draw a tangent over here. Now you remember the angle cannot be taken from this direction. It should always be taken from the x-axis like this. Okay, so this angle is obtuse angle. So for obtuse angle, what is slope? Negative. Okay, so here for this line the slope is negative, and for this line the slope is positive. Okay, let us move on to next slide. Here we discuss about conic sections. What is a conic section? In mathematics, a conic section, or simply conic, is a curve obtained as the intersection of the surface of a cone with a plane. Okay, the three types of conic sections are hyperbola, parabola, and ellipse, and the circle is a special case. Okay, now see, suppose there is a cone like this, and we have a plane. This plane is intersecting this cone in this fashion. Now, whatever the shape we obtain here, this is parabola. And if you intersect this plane with the cone in this fashion, we get a circle. And if we intersect the plane with the cone in this fashion, we get an ellipse. So here in the fourth case, it is a hyperbola. Okay. So mainly we focus on ellipse, circle, and parabola in this session. Okay. Now to understand about ellipse, parabola, hyperbola, and circle, first of all we should learn about eccentricity. So the eccentricity is defined as, look at this example over here. This line is called a directrix. It is a reference line. Directrix is a reference line, and this is horizontal line on which we have a focus point F. Okay, a focus point F. Now take any one point on this curve. I have plotted one curve over here. Take any one point on this curve. From that point to directrix, draw a horizontal line. Take any one point on the curve. From that point to the directrix, draw one horizontal line. That gives you PQ. Okay. Then draw one more line between the point P and the focus of that curve. Okay. Now this PQ over PF is always a constant. The value of PQ upon PF is called eccentricity. This eccentricity is always a constant for a given curve. Okay. If suppose the E value is equal to 1, the curve is parabola. If it is less than 1, it is ellipse. If it is greater than 1, it is hyperbola. Okay. Now let us look at an ellipse. Okay. So here the given one is ellipse. Let us look at all the geometrical features of this ellipse, because this is very helpful in learning gravitation lesson. Okay. Now here the line that joins two foci and the center and touching both the vertices of this curve is called major axis. It is major axis. And the vertical line passing through the center, this one is called minor axis. Major axis and minor axis. Okay. Now the distance between focus and center, this one is represented as a C. The distance between center to this point is termed as B. Okay. That means semi-minor axis. Here B is called a semi-minor axis, and here A is what? The distance from one end to the center of this ellipse is called semi-major axis. Here A is called a semi-major axis, and B is called a semi-minor axis. Now we have another definition for eccentricity. Here eccentricity is equal to distance of focus from center. That means C. In the diagram we can say from the focus to center, what is the distance? C. So distance of focus from center upon semi-major axis. What is semi-major axis here? A. Okay. Semi-major axis is A. So the other definition of eccentricity is what? It is a ratio of distance of focus from center, which is C, upon semi-major axis, which is A. Okay. So this is the appropriate definition of eccentricity. Now coming back to these values, if E equal to 0, it is a circle. If E equal to 1, it is a parabola. If E less than 1, it is an ellipse. If E greater than 1, it is a hyperbola. Okay. Next, look at the standard equation of ellipse. The standard equation of ellipse is x square upon a square plus y square upon b square is always is equal to 1. Okay. Where x and y are the coordinates of any point you take on the ellipse. Okay. Any point you take x comma y on ellipse, and where a and b are the semi-major axis and semi-minor axis respectively. Okay. You take any point on the ellipse and substitute those values, xy values over here, and a value, b value all in all, then this equation always gives you 1. So this is the standard equation of ellipse. Now as we have discussed, circle is a special case of ellipse only. Okay. So what is the special case? If suppose a is equal to b in this equation, if you substitute a equal to, now if you simplify this equation, it becomes x square plus y square is equal to a square. Sorry, it is a square. Where a is what? A is the radius of the circle. Okay. So the equation becomes x square plus y square is equal to a square, where a is the radius of the circle. Okay. Now this is again another important relation between semi-minor axis, semi-major axis, and eccentricity of ellipse. You make a note of this equation because it is very important in equations of ellipse. Now let us look at parabola. The standard equation of parabola is y is equal to ax square plus bx plus c, where a not equal to 0. Now look at first shape of the graph. If suppose y proportional to x square, earlier we have seen y proportional to x, then the graph will be a straight line. But now the relation is y proportional to x square. Okay. So let us take x value 0, then y value becomes 0 square is 0. Okay. Now let us take x value 1, then 1 square becomes 1. Now let us take x value 2, then 2 square becomes 4. Now let us take x value 3, then 3 square becomes 9, isn't it? Now let us take x value 4, then y becomes 16. Now plot the graph for these values. This is on x-axis, this is y-axis. Now the graph, the values for x changes like from 0, 1, 2, 3, 4. So the scale on y-axis you take it as a 5, 10, 15, 20. Okay. Now look at first coordinates 0, 0. So it starts over here. Okay. Next coordinate x coordinate 1, y coordinate also 1. It will be somewhere here. It will be somewhere here 1, 1. Next 2, 4. 2, 4. It also will be somewhere here. Next 3, 9. So it is slowly increasing like this. Now 4, 16. For the value of x as 4, it is 16. It is around somewhere here. Now look at the graph. The graph comes like this, a parabola. Okay, upward parabola. This is upward parabola. Okay. Now look at another shape here, which is y square proportional to x, or x proportional to y square this time. Okay. If suppose you take y value 0, x value 0. Okay. Take y value 1 and x value is 1 square, which is 1. Take y value 2. Now x value is 2 square, which is 4. Now take y value 3, and 3 square is 9. Take y value 4, and 4 square is 16. Plot the graph for this. This is x-axis and this is y-axis. On x-axis, let us take the values like it is changing from 0 to 16 now. So let us take the values 0, 5, 10, 15, and then 20. On y-axis, let us take the values from 0, 1, 2, 3, and then 4. Okay. So first coordinates 0, 0. Next 1, 1. 1, 1 means it will be somewhere here. 1, 1. Next 4, 2. 4, 2 will be somewhere here. 4, 4, 2. Next 9, 3. 9, 3 will be here. Okay. Next 16, 4. 16, 4 means it is somewhere 16, 4. It is here. So look at the graph. It comes out to be downward parabola. Okay. So these are the basic shapes of the parabola. Upward parabola and downward parabola. If the relation is y proportional to x square, it is an upward parabola. If the relation is x proportional to y square, it is like this. Okay. This is all about basic coordinate geometry. That's it for the day.